Uninterruptible power supplies, often called UPS, are composed of batteries, an inverter, and a charger. The purpose of the UPS is to maintain power to critical loads when the main power source fails or experiences voltage fluctuations. When the incoming AC voltage drops below a preset level, the UPS automatically switches to battery power, ensuring an uninterrupted power supply to the connected equipment. The specific voltage level at which a UPS activates its battery backup is referred to as the low voltage threshold. The actual low voltage threshold varies depending on the UPS model and the manufacturer's design. A typical range for this threshold falls between 95 and 105 volts AC. This range allows the UPS to ride through minor voltage dips without unnecessarily draining the battery, while still providing protection against significant power disturbances. Some UPS models offer adjustable low voltage thresholds. This feature allows users to customize the UPS response to voltage fluctuations, tailoring it to the specific requirements of their equipment and power environment. Adjustable thresholds can be useful in situations where the incoming power supply is known to be unstable or prone to voltage variations. Some examples of common low voltage thresholds for a UPS include 97 volts AC, 99 volts AC, 102 volts AC, and 105 volts AC. These values represent typical settings found in a variety of UPS models. To determine the exact low voltage threshold for a particular UPS, it is essential to consult the manufacturer's specifications. This information is typically found in a user manual or product documentation. The specifications will provide the precise voltage level at which the UPS is designed to switch to battery power. Understanding the low voltage threshold is crucial for ensuring that the UPS operates correctly and provides the intended level of power protection. Setting the threshold too low can lead to frequent and unnecessary battery usage, while setting it too high can delay the switch to battery power and potentially expose connected equipment to voltage fluctuations. The low voltage threshold is an important parameter that determines when a UPS transfers from mains power to battery power. The threshold is usually in the range of 95 to 105 volts AC, but it can vary by model. Consulting the UPS specifications is crucial to determining the exact low voltage threshold. Understanding the function of a UPS requires knowledge of its components and operation. Here is a more detailed explanation. The batteries store energy for use during power outages. The inverter converts the direct current DC power from the batteries into alternating current AC power suitable for electronic devices. The charger maintains the batteries at full charge during normal operation. When the mains power is within acceptable limits, the UPS passes the AC power directly to the connected equipment, while simultaneously charging the batteries. When the mains power fails or drops below the low voltage threshold, the UPS immediately switches to battery power. The inverter converts the DC power from the batteries into AC power, which is then supplied to the connected equipment. The transfer from mains power to battery power is designed to be seamless, ensuring that there is no interruption in power to the critical loads. When the mains power is restored, the UPS switches back to mains power and resumes charging the batteries. There are different types of UPS, each with its own characteristics and applications. Standby UPS is the most basic type of UPS. During normal operation, the load is powered directly by the mains power and the inverter is in standby mode. When the mains power fails, the UPS switches to battery power. Line interactive UPS regulates the voltage of the mains power before it reaches the load. This type of UPS can protect against voltage sags and surges. Online UPS continuously converts the incoming AC power to DC power and then back to AC power. This provides the highest level of power protection as the load is always powered by the inverter. The choice of UPS type depends on the specific requirements of the application. For critical applications such as data centers and medical equipment, an online UPS is typically recommended. For less critical applications, a standby all-line interactive UPS may be sufficient. UPS are rated by their power capacity, which is measured in volt-amps, or VA, or watts. The power capacity indicates the maximum amount of power that the UPS can supply to the connected equipment. When selecting a UPS, it is important to choose one with sufficient power capacity to handle the load. It is also important to consider the runtime of the UPS, which is the amount of time that the UPS can supply power to the connected equipment during a power outage. The runtime depends on the size of the batteries and the load. The installation and maintenance of UPS are critical for ensuring their proper operation and longevity. Proper installation involves connecting the UPS to a dedicated circuit with the appropriate voltage and amperage rating. It also involves grounding the UPS to prevent electrical shock. Regular maintenance includes inspecting the batteries, checking the connections, and cleaning the UPS. Batteries should be replaced every 3 to 5 years, or as recommended by the manufacturer. Proper ventilation is also important for preventing overheating. UPS are an essential component of any power protection strategy. They provide a reliable source of backup power during power outages, protecting critical equipment from damage and data loss. Understanding the different types of UPS, their features, and their installation and maintenance requirements is crucial for ensuring that they operate correctly and provide the intended level of protection. The low voltage threshold is just one aspect of UPS operation, but it is an important one. By understanding the low voltage threshold, users can ensure that their UPS are properly configured to provide the best possible power protection. In summary, UPS are essential devices for protecting critical equipment from power outages. They consist of batteries, an inverter, and a charger. The low voltage threshold determines when the UPS switches to battery power. The typical low voltage threshold is between 95 and 105 volts AC, but it can vary by model. It is important to consult the UPS specifications to determine the exact low voltage threshold. Proper installation and maintenance are essential for ensuring that UPS operate correctly and provide the intended level of protection. The purpose of a UPS is to provide continuous power to critical loads during power outages or voltage fluctuations. When the incoming AC voltage falls below the low voltage threshold, the UPS switches to battery power. This transfer is designed to be seamless, so there is no interruption in power to the connected equipment. The low voltage threshold is an important parameter that determines when the UPS transfers from mains power to battery power. This threshold prevents unnecessary battery usage due to minor voltage fluctuations. Some UPS models offer adjustable low voltage thresholds. This allows users to customize the UPS response to voltage fluctuations, tailoring it to the specific requirements of their equipment and power environment. It's always important to consult the UPS model specifications to determine its exact low voltage threshold. The specifications will provide the precise voltage level at which the UPS is designed to switch to battery power. Understanding the low voltage threshold is crucial for ensuring that the UPS operates correctly and provides the intended level of power protection. Ensure the UPS is properly grounded to prevent electrical shock.